Okay, so let's start. So welcome to the Edge project presentation. So this project is defined as the software foundation for IoT devices. Let me introduce myself. So my name is Stéphane Minchin. I'm a director of customer care at MicroEJ. So I'm in charge of customer project and training support for the company. My background is close to 15 years of embedded system specialties in RTOS, embedded development in C and Java. A couple of words about the company MicroEJ. So we are a software editor. We provide an operating system for IoT devices. So that's all embedded device. Typically, we're talking about ARM, Cortex-M, and Cortex-A devices. So that's all of the IoT industry. We provide software tools and runtime licenses for our customers to develop with the operating system. A couple of numbers on the company. We had a $5 million funding in 2011, and it's almost $20 million of R&D investment to create the platform, the operating system. Our offices are in France, Nantes and Massy, near Paris. And we have sales offices in Germany and in the US. It's Austin and Boston. Today, we have made partnership with the key silicon vendors like ST, Renesas, NXP. Most of embedded software supplier, we're talking with MicroChip, ThreadX, these kind of guys, and also hardware vendors, distributors, Avnet, this kind of company. Our expertise are in all embedded devices, so from hardware, microcontroller, virtualization, virtual processor, compilation, linker, software engineering, and also software process development. If we look at a big picture of operating system that will enable the IoT industry, we can divide in two the hardware. First one is a microcontroller. We're talking 32-bit here. The other part is microprocessor that runs Linux, Android. And here, MicroEJ operating system is designed mainly to run on microcontroller, so that's ultra low-cost hardware. We're talking about kilobyte of flash, not megabyte. And we also target the smallest microprocessors. We're talking Cortex-A, single core, mainly single core devices. And that first part of the market is like 75% of the IoT industry will run on those kind of hardware because it's a lower cost in terms of bill of materials. And if you look at the battery life, is really important. We're not talking about a one-day life. We're talking about weeks life on a single battery. So our product is called MicroEJ. It's defined as an SDK for the operating system and the tools. If you want to develop your own firmware, so that's a device software development. We have the studio. It's for application development, so it's based on Java. And we have an application store for wired or wireless application deployment over the air, over whatever link. So now let's go to what we call Edge and introduction to IoT. The Edge project is an abstraction API for the embedded system for the IoT industry. We have an hardware abstraction for peripheral management, controller communication, that's going to be serial connections like UART, CAN, SPI, I2C. And we also have digital and analog I/O, so GPIO, ADC, DAC. So the scope of the Edge project is really to target resource-constraint microcontroller. We will not talk about high-end microprocessor devices. It's really for what's going to be the main focus for the IoT industry. The scope of the project is also to provide ready-to-use software for the target hardware. So we're going to talk about some hardware later. And also, we want to define a modular and easy-to-port framework. We're going to support different hardware, different frameworks. So that's what we aim with this project. So this is an Eclipse IoT project. It's in incubation status. And we did recently the initial contribution. So that's actually in review by the Eclipse Foundation. Now let's take a look at the IoT topology. You can divide it in 3 parts. There's on the left at the devices. So that's going to be anything that's going to be in your home, on you, in your car. So that's going to be smartwatch. That could be your oven, your anything that will be made by the IoT industry. It's usually either directly connected to a server. That could be 3G connection, LoRa, anything, or it could go through a gateway. So the gateway is typically your internet connection at home. That could be the gateway for you. And now if we look at the hardware used for that, typically here you're going to find 8 to 32-bit microcontroller. Usually it's frequency 200 megahertz maximum. Usually it's going to be in the 10 to 30 megahertz range because most of them will run on battery. We're talking about less than 1 megabyte of flash, less than 512 kilobyte of RAM. The gateway could also be made with a microcontroller. I mean, if it's not like a 5 Ethernet port connector, you can run a microcontroller on the gateway. Not a problem for that. And typically, the small kernel to run on that, it could be like FreeRTOS. It's not Linux. It's not Android. Then you have the gateway. That's what we talk about microprocessor. It's going to be gigabyte of flash, gigabyte of RAM. It's typically Linux and Android. And it could be a bit of the IoT device, some of them. It will be the main focus of the gateway. The hardware that we use in this project, in the Edge project, will be the STM32F4 Discovery. So that's a board from ST. It's a 32-bit Cortex-M4. It's a couple of hundred of megahertz, less than 200K byte of RAM, 1 megabyte of flash. That's typically one of the target of the project. The second one is the Raspi, 32-bit quad-core A7 core. We have 1 gigabyte of flash, 1 gigabyte of RAM, and an SD card. So that's going to be the two main hardware we're going to use on the project to demonstrate the minimum set of API for the IoT industry. If we look at the application field on the project, the library is at the edge of the IoT. So that's what it's called, Edge. And the J stands for Java, for sure. And we got here, it's sensors, actuators, that's the network, and here, that's the internet. That's all the services in the cloud. So now let's talk about the Edge device configuration. The list of Java API for Edge is the minimum execution environment provided by the Edge-compatible devices. So that's going to be intersection between Java SE, MicroEJ, and Android. So that's that package includes java.lang, java.util, java.io. So that's the minimum. Any questions so far? If we now look at the layer level, we're going to get the execution environment. That's the edge device configuration we just seen. Library is going to be the edge API, and the edge application could either use the edge API or it could use the edge device configuration directly. So this ensures great portability of the code. Let's take a look at the edge API and the services it's gonna bring to the IoT world. On this is a board example. You got serial communication interfaces like the controller communication. This is CAN, serial port. We're gonna get analog input with potentiometer, GPIOs. That's analog input, usually connected to just GPIOs or ADC. And then you got peripheral management. It's going to be LCD or devices like USB that you can plug and unplug with dynamic registration. The peripheral management system of the Edge API, there's a list. It lists peripherals of the platforms. So could be microcontroller peripherals, UART, timer, USB. Could be the board peripherals. That's the screen, the display, button, LED, sensors. And there are also external peripherals. That's the one you plug on the board. So that could be USB devices, Bluetooth devices that's going to be paired to the board. There's also the peripheral plug, unplug notification system. So if you plug, let's say, a USB device, that is a USB CDC, it's going to register a new serial communication interface. So that has to be dynamic plug and dynamic unplug. Controller communication interface. We have a connection to external devices. We talked about that, so that's UART, SPI I2C, CAN. The interface, it's going to be connectable interface. The connection is just described by the string. And you're going to see there an example with a serial port. So that's a serial port, which is a peripheral manager.list, which is serial port.class. And you got the connection where it's a serial port.open connection with a string. For digital and analog input-output, it's managed by the controller pins. The API is very similar to what was used by Arduino, the C API of Arduino, which is basically some set and read GPIOs. You got general purpose, like for the LED buttons. ADC is used for potentiometer, temperature sensor, or light sensor. You got DAC for speaker or light dimmer. And PWM is used for motor control. On the Edge API for the I/O, we identify the pin by the port and an ID. So the port name could be MCU specific, so it's port A, port B, that's specific to one particular microcontroller. It could also be board specific. It could be G1 or G2, that's really specific to one board. Or it could be a standard. Right? When we talk about Arduino, we know that it's going to be I2C over there, probably ground. UART here, GPIO, PWM, so that's defined by the standard. And the board itself and the shield that can plug onto that is compliant with that standard. So it could be microcontroller specific, board specific, or standard specific, and that's supported by the Edge API. Now let's talk about reference implementation we're going to have. We're going to get the first implementation with peripheral management, UART, USB CDC, so that's device serial port, GPIO, DAC, and ADC. First hardware is going to be a microcontroller from ST. That's a F7 Disco board. It's a Cortex M7 at 200 MHz, 8 MB of RAM, so that's SD RAM, and 16 MB of flash. That's something like 2 MB on chip, plus probably 16 outside of the microcontroller. The platform is going to be MicroEJ operating system, FreeRTOS as a kernel scheduler, and STM32 Cube for the basic C driver of the board. The second reference implementations we're going to use is the Raspi version 2. It's a quad Cortex A7 at 900 MHz. It's 1 gig of RAM, and we're going to use a Kura platform, OpenJDK over Linux. That's the two reference platform two reference implementation we're going to use on the Edge project. Now, if we look at the features, a PC simulation will be provided. So the PC simulation will integrate hardware in the loop solution. So with this kind of architecture, the peripheral accesses are delegated to a real device. That means that if you use a GPIO or an ADC to read something, it will connect to a specific hardware using Ethernet or serial connection to get the real ADC value in the simulator. So that's hardware in the loop. So let's look at the demo I'm going to show here. We're going to use the microcontroller, the F7 Disco board. We will get the Arduino multifunction shield, which provide buttons, potentiometers, and also temperature sensor. And we're going to use MicroEJ operating system on top of that to execute the Edge implementation. So I'm just going to try to enable the camera here. Just wait 1 second. Sure, that's fine. Okay, I'm going to show it like this. So you'll be able to, this is a firmware. So the board is loaded with a firmware that is made by MicroEJ. So that's a MicroEJ OS booting here. There's a couple of apps previously installed. So there is an SD card where all the applications are already installed on the SD card. And one of them is called a pot graph. So that's potentiometer and the graph. So I'm going to just click on it and launch it. So it just draws some curve, and I've got several modes to use that. The first one is a simulation. So it just takes random data from just random value. I'm just going to connect to what we call the Easy Shield version 1. So that's the shield over there which give me access to buttons and potentiometers. And if I just play with the buttons over there, I'm just going to get real value through the Edge API, and same for the potentiometers. So this is using GPIOs, LEC, DAC. I also have serial communication with some other graphs. So this is the first implementation of the Edge. And we're going to provide that to the project. That one is already, the contribution has been made. The second implementation for the Raspberry is going to come soon. Okay, that was the demo. And just to conclude about getting starting with the Edge implementation, you can find on this URL, so that's developer.microej.com, getting started. You'll find MicroEJ Studio, which is the IDE to develop in Java for this board, for this firmware, to get the same kind of app running here. So the MicroEJ OS APIs for now includes UI, so that's widgets, any sample codes to start HMI applications. You got network interface. So the first firmware we have is a wired connection. We're going to have a Wi-Fi connection with another shield that you will plug here. That's coming soon. You got, on the top of that, multiple libraries, REST API, OAuth library, SSL, MQTT, CoAP. So all these libraries are available and running on top of the operating system. You can get access to sample code. So that's all the source you're going to get started developing some app. So it's Hello World, widget, network, smartwatch. The Edge contribution is going to be published on the Eclipse Edge project. And we're going to launch a new store, which is communitystore.microej.com. So we're going to have a contest that is going to be launched between, not sure if it's going to be June or maybe pushed to September, but it's going to be a contest for app developer to use this firmware, use this Studio SDK, and you can develop your own app, submit that to the store, will promote and promote in several categories a couple of apps that will be published on our store. So that's going to be probably in September. But you can already start to download the SDK and the studio, made your own app, use the Edge API on this first platform, and submit your own applications. Okay, do you have any questions?
Yes,
yeah, sure.
Kura and Edge.
Yeah.
Are you talking with the Kura team?
Yes.
To have the common device abstraction, because they are now using their own?
Yeah, the abstraction with Kura is different. Kura is mostly designed to run on a microprocessor. Let's take an example about GPIO. If you look at the API, it's one object per pin. So if you have 200 pin, 200 objects. We have a different API because we want it to run on resource-constraint hardware. So we're talking about one object per port. So one port is 32-bit, usually, on this kind of microcontroller. So we define Edge as a minimum set of API for the IoT industry. And it's not going to be microprocessor. It's going to be a microcontroller. So we want the minimum API really to target resource constraint, not having like a generic APIs that will not match microcontroller with only a couple of kilobytes of RAM, not megabytes. But we know the Kura team and we know them. So for sure, when we could use the same API, we will of course align and use the same one. The Raspberry implementation will be on top of Kura. So we'll see for each API, but maybe for some, this will just be the same exact API of Kura. But at least it guarantees that when you use Edge, you'll be able to run on both Raspi and the Cortex M7 as well. So that's a minimum API that ensures you that whatever you develop with Edge, it's going to run everywhere.
How is it going to be distributed? In what form? In the binary?
Source. So you'll get the source of the Edge implementation.
So it's up to the developer to compile it using its own compiler?
Yes. So there will be an implementation with MicroEJ. That's the first contribution. And the second implementation will be based on Kura and OpenJDK on top of Linux. And you'll get source for both. Yeah.
What's the smallest size of microcontroller you target for? I mean, this is definitely not going to be able to run on an Arduino, right?
So Arduino, like I said previously, Arduino, it's 8 bits, 32 bits as well. So Cortex M, M3, M4. It's also Intel processors now. But if we look at the 8-bit, I mean, we could run on 8 bits. The first, it could, because we made the first prototype of MicroEJ was running on an AVR X Mega. It's not a commercial product. It makes no sense, no economic sense to make a COTS product, but we run on Cortex M0, 128 kilobyte of flash, 16 kilobyte of RAM, and we do a Bluetooth with display, black and white display. You'll find a video on our website, and we have a platform with UI and complete set of widgets running on top of a Cortex M0 at 20 megahertz. So there's no performance problem to run on that.
Good. Thanks.
I would like to show how, when you restart your machine, how long it takes to restart it.
So the time to install or the time to boot? So the time to boot the operating system, the Java virtual machine boots in a couple of milliseconds. We're talking about, let's say, 2 to 4 milliseconds on a Cortex M devices. Then you got the libraries and the UI, so that depends on the controller. But here, you see that we're not talking minutes. I'm just pressing reset just to erase the SD-RAM, because it's going to keep the buffer, so you won't see anything. But that's good. So it boots in milliseconds, the operating system, including the network, UI, storage.
Is it possible to set the application to auto start, like in jQuery?
Yes. So for this operating system and this firmware, you see there's some app I can download and install. So that one, which is gray, it is not installed. But someone like About and this one is pre-installed. That means this app, when we built the firmware, we used the component framework and we just said, okay, take that one as a system application, and it's included in the system. But it could be one on the application store. It's not. It's the compilation time. You decide which app you want to put on the store and which one you can define as a system app. So that binary is the one available. That's the second line firmware for STM32F7. That's the one you're going to get. You can flash it yourself here. We have a couple of boards that were given by ST. Thank you, guys. Not sure if you can see you. Yeah. So you get some more. You get a couple of boards, You just have to flash the firmware, install the studio, and you can push your app. If you want to see a demo over there, we've got a booth where you will be able to see our simulator, because every app developed with MicroEJ can run instantly on the simulator. So that includes UI development, network, storage, file system. Everything could be designed on your PC and test on your PC before deploying it on the board. Yeah, sure.
What kind of debugging infrastructure you provide for writing applications?
So we do not have Java debugging on board yet. We are working on it. So the debug could be done with the simulator. It's the same binary, the same bytecode is debugged on the simulator, and then the same bytecode is running on the target. Then we got trace capability at runtime, but trace only, not breakpoint for now.
Trace for the IDE or trace to the SD card?
No, it's trace, local trace that you could direct to the serial interface typically. And coming soon, that's going to be breakpoint, typically what you have with a C debugger, putting a breakpoint on a specific instruction. It's a bit more complicated with Java. We have it working, but it's not released as a product yet. So what we do want in the future and with the context is to encourage you guys to develop apps with Edge to help us define the next standard for the IoT industry. This set of minimum API that will run everywhere. So feel free to help us, and make sure you drop by if you want to get aboard and do some development with us.
Great.
Any more questions?